So basically all that the word isomer means is a relationship. So we're going to be looking at different molecules and defining the relationship between the two. Just like you have a different relationship with your mom than you do your sister, different molecules have different relationships to each other. And so we're going to be talking about how to determine whether or not there's any relationship at all, so if it's an isomer or not. We're going to be talking about if we do know they're isomers, what type of isomers are they? So let's start at the top of our flowchart. The first step that you need to do when you're looking at two different molecules is ask yourself, do these molecules have the same molecular formula? If the answer is no, then they're not isomers. So you can see in this example, we have two molecules, but they have different molecular formulas. That means they really don't have an isomeric relationship at all. So if you ask yourself, do they have the same molecular formula, and you answer yes, then you can determine, okay, they are probably isomers. So you have to ask yourself then, what kind of isomers are these? Because there are different types. So that leads us to the next question. We know they have the same molecular formula, so we know they're isomers, but do they have the same connectivity? And in order to determine this, you need to look at the molecule itself. So let's look at that. So if they do not have the same connectivity, but they do have the same molecular formula, then they are constitutional isomers. And constitutional isomer is exactly what I just said. So an example of that would be something like this compared with something like this. So in both of these molecules, we can see that we have two carbons. We can see that we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 hydrogens. And we have 1 oxygen. So both of these molecules have the same molecular formula. However, they do not have the same connectivity. Notice that this oxygen in this molecule is connected to 2 carbons only. The oxygen in this molecule is connected to a carbon and a hydrogen. So while they do have the same molecular formula, they're not connected the same way. They're like Legos that got taken apart and re-put together in the wrong way. So in that case, these are constitutional isomers. The way they're constituted, how they're made up is different. But if you know they're isomers and they have the same connectivity, they are probably going to be stereoisomers. So again, from the top, we have two molecules that have the same molecular formula. They are connected in the same way, but they are still somehow different. And the way that they're different is in their 3D arrangement. So while they are very similar looking, the way they're arranged in space is different. So the next question to ask yourself is, are these non-superimposable mirror images? And that sounds like a lot of words, but it's actually not too difficult of a concept. So non-superimposable mirror images is going to be something like your hands. Your hands both have 5 fingers, so in that case, they would have the same molecular formula and they're connected the same way. You have your thumb connected to the same side as your arm as the other side as well. However, our hands are mirror images. You can see that here. And even if I turn it around, my palm is different than the back of my hand. There's no way I could rotate one of my hands to be exactly like the other hand. That's why if you put gloves on and you accidentally put it on the wrong hand, it doesn't fit. Your hands are non-superimposable mirror images. There's no way I could change one of my hands to be exactly like the other one. And that's the same idea with molecules. When you have a molecule that are stereoisomers and they are mirror images, that is going to be called an enantiomer. So an enantiomer is going to be something like this. Let's say that we have a mirror right here. And then we have a carbon with a hydrogen, an OH, a chlorine, and a fluorine. Across that mirror, we would have the same thing, but the mirror image of it. So our OH would still be up top, our fluorine would still be on the bottom, but we're drawing the mirror image of it. So these two molecules have the relationship of enantiomers, and there is going to be another video a little more in depth on what an enantiomer is and how to determine that more definitively. But this is just kind of the overarching idea. So the last classification we have is diastereomer. So diastereomers are going to be two molecules that have the same molecular formula, they have the same connectivity, but they're not mirror images. And again, there's going to be another video on what exactly diastereomers are and how to determine whether molecules are enantiomers versus diastereomers. But for now, we're just going to keep this broad idea in mind. They're very similar to enantiomers, but enantiomers are specifically mirror images, whereas diastereomers are not mirror images of each other.
I hope you found this video to be really helpful. The concepts and information presented in these videos will be true no matter what Organic Chemistry 1 class you are taking. However, the concepts presented in this video are referencing material currently covered in Baylor University's coursework. Remember, if you are a currently enrolled Baylor student, we offer free tutoring services. Our Tutoring Center is located on the first floor of the Sid Richardson building. You will find all the details you need about these services on our website, www.baylor.edu/tutoring. You may schedule a free 30-minute one-on-one tutoring session online or just drop in during any of our open business hours. For more information about our current services, please visit our website. Thank you.